All right, now part two. Just to kind of review a little bit of part one, we were just talking about how sine value correlates with um, the y, and cosine correlates with x, and tangent is a relationship of opposite over adjacent or y over x. So as we saw before, is sines are going to stay positive when the y value is positive, and cosines when the x values are positive, the cosine is going to stay positive. So we got quadrants 1 and 2 for sine, we got quadrants 1 and 4 for cosine, and then tangent we were talking about is taking a positive divided by a negative. So quadrant 2 for sine divided by quadrant 2 for cosine yields me a negative. So it's a positive divided by a negative gives me a tangent. Well, now, the reason that this is so important is because these past examples, I've been giving you the ordered pairs to find the relationship and telling you what quadrant it is. Well, now we're going to make you process a little bit when I give you one of these six trig functions, and I'm going to give you a restriction on the domain or the range. So what that kind of pertains to is that when the notation to see when things are positive. So from 0 degrees to pi, sine is going to be positive. So any relationship from 0 to 90 to pi over 3 to pi over 6 to pi over 3, those are all going to yield a positive y value. When you type in your calculator, when you find the value, when you calculate it, it will always be positive. And we're going to kind of be building on this concept for the next 4 or 5 lessons. And then it's negative from the bottom part. So when this is pi, and this is 0, and this is 3 pi over 2, or 270 degrees, and this is pi over 2, but we're between pi and 2 pi is when it's going to be negative. And that same kind of idea kind of portrays to cosine. So instead of it going, left and right, it's now going to be up and down. So when we go from a negative pi over 2, which is down here, to a positive pi over 2, which is up here, so we got a positive pi over 2. And the negative pi, you could also think of this as 3 pi over 2 to, I would say 5 pi over 2, but we can just kind of eliminate that idea. Actually, so I apologize for that. I want you to kind of think negative. The negative just means you're going the opposite direction again. So then a negative means that we got to go from pi over 2 to 3 pi over 2. That is going to yield me a negative. So this is my restriction to the values, the outputs. In other words, the range of it. And notice on the tangent one, I didn't write this in yet because these can kind of be difficult to write, I guess you could say. This is going to be a lot of analysis of what's going on with sine and cosine. So since tangent is a relationship of y over x, if you know these four relationships and how they correlate to the unit circle, to a visual representation, tangents is going to kind of fall into place. So if one of them is negative, tangent's got to be negative. And if both of them are negative or both of them are positive, then they're both going to be positive because negative or negative is a positive. So the domain for positive is going to be anywhere from 0 to pi over 2, and also from pi to 3 pi over 2. And again, just to reiterate, because my chicken scratcher is not looking very good. So from 0 to pi over 2, we're positive. And from pi to 3 pi over 2, or 180 to 270, we're going to have a positive tangent value. When we get to the negatives, though, we're going to have from pi over 2 being your lower bound of the angle to your upper bound, which is going to be pi. So this is really representing quadrant 2. And then from 3 pi over 2 less than or equal to 2 pi. Sometimes you might see this as negative pi over 2, between negative pi over 2 and 0 or 2 pi. Just keep in mind, 0 and 2 pi are the same thing. 0 just means you haven't gone anywhere, 2 pi has gone all the way around. But as we know, coterminals, that just means they've repeated those values. Alright, so a little, like I said, refresher, sines y, cosines x, tangent is relationship of those. The O divided by the A. Sorry about that. Got a little bit of a cold going through our house right now, so I'm trying to make sure we're handling that. So sorry about that. All right, so let's kind of apply this. Why this stuff is so important. So we want to keep in mind sine, cosine, tangent, and then cosecant matches with the sine, secant matches with cosine, and tangent is not y over x, but it's x over y. It matches the same sign. That's what our goal is getting out of this one. So let's do an example. Example 3 here says find the values of the 6 trigonometric functions for the theta. I'm giving you a relationship of 4 over 5. So I'm saying cosine of theta, so cosine of some angle, has a relationship of 4 over 5. So right now, all I know from this, and what I need to get from this, is that cosine right now is positive. And since cosine is talking about my x value, when it comes to the unit circle or a visual or my left and right movement, what quadrants is cosine of x positive? And we're going to get quadrants 1 or quadrants 4. So right now we know this picture is either going to be going up or it's going to be going down. Let's kind of just draw our idea here. We got our crosshair. So it's either going to be going up with a ratio of 4 over 5, or it's going to be going down with a ratio of 4 over 5. So then this is where we really need to look at our restriction in terms of where are we sitting. So when we say pi to pi over 2, then we're talking here is pi, here is 2 pi. Sorry, I didn't mean to say pi over 2. So therefore, if my cosine is positive here, and it needs to meet this restriction. So I need to meet this restriction, and I need to meet this restriction. So where do these two overlap? Well, if we look from pi to 2 pi, that's going to be quadrants 3 and quadrants 4. So the overlap is the fact that we have a quadrant 4 and a quadrant 4. That's the only way that the restrictions will meet this as well as the cosine relationship. That tells me that my angle is going to be going down this direction and my reference angle is going to be right there because it goes from the terminal side back to the x-axis. And it's always between 0 and 90. Excuse me for a minute, sorry. So now, because I know cosine is adjacent over hypotenuse, or we look at it as, sorry, I don't want to write or there. We look at adjacent over hypotenuse or x divided by r. We know that the 4 is going to have to go here because that's adjacent to my reference angle, and the 5 then is my radius, which is leaving me my unknown of my y. My unknown right now, but as we know, we take the Pythagorean theorem, a squared plus b squared has to equal c squared, so therefore the y value is going to be 25 minus 16, which is 9, so the square root of 9, which is equal to 3. But I also want to make sure that I keep the signs in here. Since we're in quadrant 4, we got a positive 4. Your radius will always be positive. Cannot be a negative radius. We can't talk negative distances, regardless of what quadrant we're in. But then the y value here has to be negative because I'm in quadrant 4. X is positive, y is negative. Positive x, a negative y. Now I have all the information I need to be able to answer sine, cosine, and tangent. I know 4 over 5 is my cosine. I know my secant is going to have to be the reciprocal of that, so that's 5 over 4. My sine from my reference angle is opposite over hypotenuse. So we're looking at negative 3 over 5, which makes my cosecant 5 over negative 3. Notice reciprocal. Notice opposite over hypotenuse, x or y over r. So tangent-wise, we're going to have then negative 3 over 4. And then negative 4 over 3. So both cotangent and tangent are negative. Cosine and secant are both positive because those are pertaining to the x values. And sine is negative because that pertains to the y values. You have completed what I'm looking for. So the main new thing is that we've talked about the relationships I'm going to now start restricting your range and your domain to find out what is truly happening at this angle. And as we move forward, this angle is going to change. It's going to mean a lot. We're always going to try and get things to be smaller, reduce values. So we're just building into the cornerstone behind trigonometry. So what I want you to do next is I want you to take some time right now to practice one of these on your own. I know it says example 3. This should say example 4. My mistake there. But no big deal. I'm looking for you to see if you can finish the rest of these based on these restrictions. And because Notebook doesn't have the symbol pi, I use 3 pi over 2. All right, so take some time, pause the video, try and practice these and see what you come up with. All right, now that you practice this, we kind of want to get an idea here. Tangent, negative. Because tangent is negative, we're looking at quadrants 2 or we're looking at quadrants 4. There's my restrictions on those because tangent has a negative value. And then my restriction for pi over 2, this is talking about 90 degrees. So this is up there at the top of my crosshair. So I'm sitting here between there. So therefore, this is talking about quadrants 2 and quadrants 3. Where's the overlap? We got overlap in quadrant 2. So that means my angle is going to be up here. And what's nice about tangent is that basically we know that this is the O divided by the A, or in other words, the Y divided by the X. So that's my sine value, that's my cosine value. So, ooh, wait a minute here. There's a mistake on this one, actually, now that I think about it. This is going to have to be... Oh, never mind. It's another mistake. This is going to be 3. Sorry for that pause and that delay. Had a mental lapse right there. So this is going to be your 3. This is going to be your 7. And then we need to put the negative on the 7 because that's the x value that's making it go quadrant 2. So there's your quadrant 2, a negative x, positive y. So 3 squared plus 7 squared. So 9 plus 49. So the square root of 58. And here is then our reference angle. So sine then would be 3 divided by the square root of 58. Cosine would be this, or cosecant would be the square root of 58 divided by 3. Cosine then would be negative 7 over the square root of 58. And this secant would be the square root of 58 divided by 7. Make sure that's negative because we know that the cosine is the x value. And then tangent would be 3 over negative 7. And cotangent would be negative 7 over 3. Again, realizing that the tangents are negative, like we have up here, which forces the cosine, the x values, to be negative because of the 2 restrictions, and the sine stays positive. So I'm hoping this went well. This is, like I said, my first screencast. I'll work some things through. What I will look for is next class for your homework-wise. I'm going to want you to complete worksheet 5.3, questions 1 through, I think it's 8. And I'll double check on that. It'll say on the board in the sub, Mr. Wastel will fill you in on this. At any point throughout this video, you feel like you need to pause it to get things written down, or you know me, I talk so fast, feel free. And then after this, you're going to have the hour to work on worksheet 5.3, 1 through 10. And then I want you to do the applications that are on the very back of that worksheet with dealing with linear and angular speed. So when I come back on Tuesday, we'll revisit this stuff. We're going to get a little bit more feedback on linear and angular speed. And then we're going to finish this lesson off. We're going to make the connection back to the unit circle, which is truly one of the second most important lessons we're going to learn moving forward. So looking for some feedback. Hope you guys have a great weekend. Stay on top of your work. Stay ahead of this. And sorry I'm not there today, but you guys have a good weekend, and I'll see you guys next week. All right. Thank you.